Hello, and welcome. Today we're going to dive into the fundamental concepts of integers, fractions, decimals, and percentages. These are different ways of representing numbers, and understanding how they relate to each other is a crucial skill in mathematics. By the end of this lesson, you will be able to: first, define and identify different types of fractions. Second, you'll be able to convert numbers between these different forms. And third, you'll be able to apply the correct order of operations in your calculations. Let's start with the basics. What is a fraction? A fraction represents a part of a whole. Imagine you have a pizza and you cut it into equal slices. Each slice is a fraction of the whole pizza. For example, if we break a unit into 10 equal parts and take 3 of those parts, we write that as the fraction 3 over 10. This means 3 parts out of a total of 10. In this fraction, the top number, 3, is called the numerator. It tells us how many parts we have. The bottom number, 10, is the denominator. It tells us how many equal parts the whole is divided into. There are a few types of fractions we need to know. A proper fraction has a numerator that is smaller than its denominator, like 3/4. This represents a value less than 1 whole. An improper fraction has a numerator that is larger than its denominator, such as 9/2. This represents a value greater than 1 whole. And a mixed number is a combination of a whole number and a proper fraction, like 4 1/5. This is just another way to write an improper fraction. Now, let's see how to find a fraction of a quantity. In this scene, you will learn how to calculate the value of a fraction of a whole number. Let's look at an example. Suppose we want to find 1/5 of 35. This phrase, 1/5 of 35 feet, means we need to divide 35 into 5 equal parts and find the value of one of those parts. So we calculate 35 divided by 5, which gives us 7. Therefore, 1/5 of 35 is 7. What if we want to find a fraction with a numerator other than 1? Let's build on that. Let's find 3/5 of 35. We already know that 1/5 of 35 is 7, so to find 3/5, we just need 3 of those parts. We simply multiply the value of 1/5, which is 7, by the numerator, which is 3. So 3 times 7 equals 21. 3/5 of 35 is 21. So the general rule is, to find a fraction of a number, you divide the number by the denominator, and then multiply the result by the numerator. Next, we'll focus on converting between mixed numbers and improper fractions. By the end of this scene, you'll be able to switch between these two forms fluently. Let's start by changing the mixed number 3 5/8 into an improper fraction. To do this, we need to figure out how many eighths are in the 3 whole units, and then add the extra 5/8. The process is to multiply the whole number by the denominator, and then add the numerator. This result becomes the new numerator, and the denominator stays the same. So we calculate 3 times 8, which is 24, and then add 5. 24 plus 5 is 29. So 3 5/8 is equal to the improper fraction 29 over 8. Now let's go the other way. How do we change an improper fraction into a mixed number? Let's convert 27 over 4 into a mixed number. This requires division. We need to find out how many whole times 4 goes into 27, and whatever is left over will be our new fraction. We divide 27 by 4. 4 goes into 27 6 times, because 6 times 4 is 24. The remainder is 27 minus 24, which is 3. The result of the division, 6, becomes our whole number. The remainder, 3, becomes the numerator of the fraction, and the denominator stays the same. So, 27/4 is equal to 6 3/4. Now you've seen how to convert from mixed numbers to improper fractions and back again. Let's move on to decimals. In this scene, our goal is to understand decimal place value and its connection to fractions. Decimals are essentially fractions, where the denominator is a power of 10, like 10, 100, 1000, and so on. The position of a digit after the decimal point tells us its value. For the number 3.27, the 3 is in the units place, the 2 is in the tenths place, and the 7 is in the hundredths place. This means we can write the decimal as a sum of fractions. So 3.27 is equal to 3 units, plus 2 tenths, plus 7 hundredths. It's the same value, just written differently. We can also combine these fractional parts. For example, 2 tenths and 7 hundredths can be thought of as a single fraction. To add them, we need a common denominator. 2/10 is the same as 20 hundredths, so 20 hundredths plus 7 hundredths gives us 27 hundredths. This shows that 0.27 is equivalent to the fraction 27 over 100. Understanding this place value system is the key to connecting decimals and fractions. Now let's talk about percentages. The objective here is to understand what a percentage is and how to convert a fraction into one. The word percent literally means per hundred. So a percentage is just a special type of fraction where the denominator is always 100. For example, the fraction 29 over 100 can be written as 29%. The percent symbol, percent, simply replaces the, quote, over 100 feet. But what if our fraction doesn't have 100 as its denominator? We can use equivalent fractions to change it. Let's try to change the fraction 3/5 to a percentage. Our goal is to find a fraction that is equivalent to 3/5 but has a denominator of 100. We need to think, what do we multiply 5 by to get 100? The answer is 20. Since 5 times 20 is 100, we must also multiply the numerator by 20 to keep the fraction's value the same. 3 times 20 is 60, so 3/5 is equivalent to 60 over 100. And now that we have a denominator of 100, we can write it as a percentage. 60 over 100 is simply 60%. So we have successfully converted a fraction to a percentage by creating an equivalent fraction. Let's tie everything together. In this scene, you will learn the methods to convert between fractions, decimals, and percentages. Being able to move smoothly between these three forms is essential. Let's review the key conversion paths. First, to change a fraction to a decimal, you divide the numerator by the denominator. For example, 1/4 becomes 1 divided by 4, which is 0.25. Next, to change a decimal to a percentage, you multiply by 100. This is the same as moving the decimal point 2 places to the right. So 0.25 becomes 25%. Finally, to change a percentage back to a fraction, you write the number over 100 and then simplify the fraction if possible. For example, 75% is 75 over 100, which simplifies to 3/4. Let's trace one value through all three forms to see it in action. Let's take the fraction 2/5. To make it a decimal, we do 2 divided by 5, which is 0.4. To make that a percentage, we multiply by 100 to get 40%. And to go back to a fraction, 40% is 40 over 100, which simplifies back to 2/5. They are all the same value. Before we tackle more complex problems, let's quickly review two key arithmetic skills, long multiplication and short division. Our objective is to refresh our memory on these procedures. When doing long multiplication like 184 times 37, it's all about place value. First, we multiply 184 by the units digit, 7, which gives us 1288. Then, we multiply 184 by the tens digit, which is 3, but we must remember it represents 30. So, 184 times 30 is 5,520. Notice the 0 as a placeholder. Finally, we add these two results together. 1288 plus 5,520 gives us our final answer, 6,808. Now for division. Sometimes we get a remainder, but it's often more useful to express the answer as a decimal. Let's look at 453 divided by 6. 6 goes into 45 7 times with a remainder of 3. We write down the 7 and carry the 3 over. Now we have 33. 6 goes into 33 5 times with a remainder of 3. Instead of writing remainder 3 feet, we can continue the division. We add a decimal point and a 0. We carry the remainder 3 over to the 0, making it 30. 6 goes into 30 exactly 5 times. So 453 divided by 6 is exactly 75.5. This is often the preferred way to write the answer. When a calculation involves multiple operations, the order in which you do them is critical. In this scene, you will learn to apply the correct order of operations. We follow a set of rules, often remembered by the acronyms BOD, MAS, or PEMDAS. This stands for brackets, orders, like powers or square roots, division and multiplication, and finally, addition and subtraction. Division and multiplication have equal priority, as do addition and subtraction. We work from left to right when priorities are equal. Let's see how this works with an example. Consider the expression 3 plus 7 times 2 minus 4. According to BODMAS, Multiplication comes before addition and subtraction. So we must perform the 7 times 2 calculation first, which is 14. Our expression becomes 3 plus 14 minus 4. Now we just have addition and subtraction, so we work from left to right. 3 plus 14 is 17, and 17 minus 4 is 13. Now let's see what happens when we introduce brackets. This time we have brackets around the 3 plus 7. The B in BODMAS tells us to do what's inside the brackets first, overriding the normal order. So we first calculate 3 plus 7, which is 10. The expression becomes 10 times 2 minus 4. Now we follow the rules again. Multiplication before subtraction. 10 times 2 is 20, and 20 minus 4 is 16. A completely different answer, all because of the brackets. We've seen how to turn fractions into terminating decimals, like 0.25. But what about decimals that go on forever? These are called recurring decimals. Our objective is to learn how to convert these back into fractions. A recurring decimal has a digit or a group of digits that repeat infinitely. We use a dot or a bar over the repeating part to write them concisely. It might seem impossible, but every recurring decimal can be written as a perfect fraction. Let's see how. Let's convert 0.4 recurring into a fraction. We'll use a bit of algebra. First, let's set our number equal to a variable, x. So x equals 0.4444, and so on. The trick is to create a second equation by multiplying x by a power of 10. Since one digit is repeating, we'll multiply by 10. Multiplying by 10 shifts the decimal point one place to the right. So 10x equals 4.44444 recurring. Now we have two equations, and the parts after the decimal point are identical. This means we can subtract one equation from the other to eliminate the recurring tail. We subtract x from 10x. On the right side, 4.444 minus 0.444 leaves us with exactly 4. On the left side, 10x minus x is 9x. So we get the simple equation 9x equals 4. To solve for x, we just divide by 9. So x equals 4/9. We've proven that 0.4 recurring is exactly equal to the fraction 4 over 9. Let's try a slightly more complex case. The objective here is to convert a recurring decimal with a 2-digit repeating block into a fraction. This time, let's convert 0.68 recurring, which is 0.686868, and so on. As before, we start by setting x equal to our decimal. Now, since 2 digits are repeating, multiplying by 10 won't be enough to align the decimal parts. We need to shift the decimal point 2 places to the right. To do that, we multiply by 100. So, 100x equals 68.686868 recurring. Notice how the part after the decimal point, the 0.686868, is now identical to the decimal part of our original x. This alignment is key. Now we can subtract the original equation to cancel out the infinite tail. We subtract x from 100x. On the right, the recurring parts cancel perfectly, leaving just 68. On the left, 100x minus x is 99x. This gives us the equation 99x equals 68. Finally, we solve for x by dividing by 99. So x equals 68 over 99. This method works for any recurring decimal. You just need to choose the right power of 10 to multiply by. Let's quickly recap what we've covered today. We started with the fundamentals of fractions, decimals, and percentages, understanding that they are all just different ways of representing the same value. We practiced converting between these forms, a skill that is essential for solving a wide range of math problems. We also reviewed the order of operations to ensure our calculations are accurate, and we explored the clever algebraic trick for turning infinitely recurring decimals into simple fractions. Mastering these concepts will provide a strong foundation for your future studies in mathematics. Thank you for your attention.